Okay, welcome back. Thanks for coming back. Thanks for not leaving. Today my talk is called Growing the Network, Spreading the Word. And you may find it interesting that the talk is about how we make I2P bigger, how we get everybody to find out about it, but it's not necessarily a talk about what I2P is. But you're going to find that out anyway. What I'm going to do is I'm going to explain how we got here and how we're where we are now and what we have to do next. And along the way, you're going to learn a little bit about what I2P is. But this is not a boring, here's what I2P is presentation, because this conference is really about where we go from here. We set up this conference where we could all get together and do some planning, talk about what to do next, and to find people that could help us. And so the way we're going to do that is for me to explain, well, how the heck did we get here? We'd hoped Lance James would be here. Lance, as many of you know, founded the Invisible Internet Project back in 2002, or IIP, which became later I2P. And so 13 years later, he was coming back to talk to us. And he's very much of a nostalgic type like I am, and it's very interesting to look at where we came from and how we got here. And so that's the talk that we have for you today. This is one of my favorite little comics. We're going to talk a lot about Alice and Bob. Alice and Bob are crypto people. You may, if you've seen any talks about crypto, Alice and Bob are always in there. And Alice is the one that starts the conversation, and she's trying to talk to Bob. So my talk will definitely have a lot of Alice and Bob in it, because that's the only way you can possibly explain communications in crypto is if you have Alice and Bob in it. As I said, we've come a long way. We started in 2002. Actually, Lance, in the wake of 9/11, was looking for a project that could really make a difference and started the Invisible IRC project, which was an IRC-focused network where people could talk to each other, do chats over an encrypted mechanism. And one thing I think he discovered is that encrypted chat only may not have been enough of a killer application for everybody to really pick it up. But that was also before cell phones. And now there actually are encrypted chats, encrypted applications going on. You see, we went through a couple different logos. This is our, I guess I shouldn't point to that screen, you can't see that. Nick, you were doing the laser pointer thing. How'd you do that? No kidding. Nice. That's a professor for you. He knows knows the laser pointer. Somewhere along the way, we got to 0.7, with the famous I2P. And as many of you know, from looking at our shirts, you may not have figured out exactly what that yellow circle is. It is not a guy holding his nose. It is, believe it or not, a magnifying glass. And he's holding on to a magnifying glass, and I don't even know exactly why or what that means. You can demonstrate that for us back there. Hold it there, see? It's a magnifying glass, not a mask. So maybe logos and graphic designers is what we need help with. I don't know. And then our current logo is down in the lower right. So I2P is very much decentralized. And one thing that means is there's not centralized authorities. There's nobody in control of the network. When people install I2P, they go get a list of other people that are running I2P, and then they try to connect to them. There's not a centralized authority saying these nodes are good, these nodes are bad, these nodes are fast, these nodes are slow. Each peer figures that out for itself. Every node is a relay. That means when you run I2P, for the most part, you're not just connecting into some sort of network that's routing the traffic for you. You become part of that network right away. And so you are always routing traffic for everybody else. And that makes it a very democratic, decentralized network where everybody is routing for everybody else. Everybody is contributing. If you're using I2P, you're contributing. And that makes it work very well. If you have to go out and beg people to flip a switch to please route traffic for other people, if you have to configure it that way, that makes it much more difficult. We are organized using a DHT, that's a distributed hash table. That's a way of finding other peers and having a decentralized directory so that if I need to connect to some other peer, I can ask this distributed directory how to get to that peer. And so we like to claim that we are fully decentralized and there's nobody in charge and there are no centralized authorities, no single point of failure. You can't take the network down. Well, as I said, this is not just a marketing talk. We're also talking about what could we do better. And so the marketing, maybe the marketing is a lie. So we'll just start right there, just start putting the dirt out there right now. Every node is a relay. That's almost true. You can configure your node so that it doesn't route traffic. We ask that you not do that. If everybody did that, the network would collapse. There's also certain nodes called hidden nodes. In some countries, like China, we detect that you're in China and we configure you to not route. It's both because of connectivity problems getting in and out of China, but also in some countries like China, it may actually be a problem if people found out that you were running I2P. The DHT is not exactly a normal DHT. It's a little different. It's got little warts, got a little strangeness. We're going to talk about that more tomorrow. And only the fastest peers are members. So even though all nodes are relays, not all nodes are part of the DHT. That means you're not part of that decentralized directory service. Only the fastest peers are. We do that for reliability. We found that for the most part, the fastest peers are also the ones that are going to be up the longest. If your I2P software is running in a data center, it's probably going to stay up. If it's running on your laptop or on your home DSL, well, I wouldn't be surprised if you turned it off when you went to bed tonight. So we found that for reliability and for simplicity, we make the fastest nodes be the DHT nodes. We like to say there's no single point of failure, but of course that's an exception too. It wouldn't be good if some of these people in the yellow shirt got hit by a bus. We think we could recover, but that actually is one of the biggest problems is there's not, some of the people, we don't have enough people running some of the things. And sometimes when we're looking for somebody to run something new, we'd rather have somebody new run it rather than go to these same old people in the yellow shirts that are running some of these essential services. And while we try and have at least two of everything, sometimes if the bus came and got one of us, it wouldn't be so good. It would be a problem. There's no centralized authorities, and of course there's exceptions to that. We have some services like the news. We have a news feed that shows up in the software, so if we want to announce something to the I2P users, we can enter it onto our news server, and poof, it will show up in everybody. Like a little, hey, here's what's happening today. We're having I2PCon. And Echelon runs one of those news services. Jeff, where's Jeff? Jeff runs one of those. We also have semi-centralized update. So we have an automated update system. And that's how we get the new versions of the software out to everybody. And a lot of these yellow shirt people do run those update servers. We only have one out proxy, and we're going to talk a lot about out proxies here in a minute. Subscriptions for naming service. So we like to say we're decentralized, and that's for the most part true. And I'm going to explain who is centralized here in a minute. So again, right off the bat, I wanted to show you this is not just marketing, that we're actually talking about some of the things that maybe we can do better. Maybe there's nothing you can do to prevent against the bus when it comes to get you, but we're going to keep working on it. So this is the main part of the talk, making I2P work, making it better, and trying to get the word out. And making it better and spreading the word are not two separate topics. They're really one and the same. We can't get better unless we get bigger, and we can't get bigger unless we get better. When it was just a few of us running it, it didn't work very well at all, but we didn't know it until we got a bunch more people running it, and then everything broke. This is a funny slide I found. This is from many years ago. This was somebody in some language trying to explain how we were different from Tor, I think. Complete with, I don't know if those are bunnies or donkeys. And I don't know if this slide were any better. It would be any better if you could read the language. But this is just an example of sometimes how hard it is to explain this software to people. So that is one example of somebody making an effort. So I'm going to try it again in my following slides, and you all can let me know if I do better or worse than this guy did. Here's another one I found. This is again from several years ago. This is another piece of marketing. Again, the PR folks up in the peanut gallery probably would not think this is a very good effort. No? So, it's great effort. It's just bizarre. So, we are a dome of protection. And now let me explain the dome of protection to you. Here's another one. This was a few years ago. We put ads on Stack Overflow, I think. This was an ad we put together, and they were offering free open source ads on Stack Overflow. Does that sound right, Tuna? Was this a Stack Overflow thing? Do you remember? We need Java coders. We need translators. I don't think we got anybody from our Stack Overflow ad. But it's actually an improvement over the previous ones. Again, graphic design-wise, kind of a mess. So let's talk about the first decade from 2002 to about 2011. These are some events that helped us grow. And part of understanding how to grow the network more is try to figure out, well, what's worked in the last 15 years? What were the things that really made us pop? As I said, Lance started the Invisible IRC project in 2002. From then that was taken over. Lance's work was pretty much scrapped and started over by a guy named Jay Random, who nobody ever met. But Jay Random's philosophy was don't publicize it until it's perfect. We're not going to tell anybody. It was before Twitter. But weren't really, he didn't want us to publicize it at all to anybody because it wasn't perfect yet. You don't want to promise things that you can't live up to, and so you don't want to market it to everybody in China, and then they all install it, and then they all get arrested or something. That would be bad. But back then it was only a few hundred users, and so even though it worked fine for a few hundred users, well, how would we know? Was it really perfect? Well, it turns out it was not perfect at all, but we only found that out once we started adding users. Anybody can make a little toy network of a few hundred people, but you're not going to be anonymous with only a few hundred people. You could just make a list of all those people, really. In late 2007, Jay Random vanished, and Jay Random was the main coder, the main Java guy. I had started using I2P in 2005. I just quit my job and was looking for something to play with. I was not a programmer by trade, although I'd done a little bit here and there professionally. I'd never coded anything in Java before. And I did some patches. We were all having some fun, contributing a little bit. And then Jay Random vanished, and he had the keys, all the passwords, all the servers. The server was paid up for another few months, but only he had the way to renew that. And so he vanished in November 2007, and in January 2008, there was a power hit at the data center, and all the servers went down. And when they came back up, about half the services didn't start, and we didn't have any of the passwords. And so that's when we realized, well, we need to get this thing distributed. It's not just about the software being distributed. Our infrastructure needs to be distributed. Again, it's about the bus. And sometimes the bus hits you. Sometimes the bus hits the data center. And so we learned a valuable lesson there. Well, it turns out JRandom never came back. And we realized, well, the thing we need to do is start publicizing this. So we started publicizing. We got on Twitter. In 2009, the Pirate Bay got on I2P briefly. Briefly, we had an I2P banner on the top of the Pirate Bay. It says friends of somebody that knew somebody over there in Sweden. Echelon and I wrote a paper for PetCon in 2009 explaining about I2P and how we did our peer selection. 2009, guy from Tor, Jacob Applebaum, met me at Hope. Maybe it's 2008, 2009, I can't remember. And said, "You guys suck. Your documentation sucks. Nobody believes you. Because your documentation is outdated or wrong, and it's a disaster on the website. And until your documentation is right, nobody will trust you. Nobody will believe you. You're a joke until at least you say what it is you're doing." And he was right. And so we stopped all development for 3 months and did that. We did some presentations. We've been going to DEF CON for the last 5, 6, 7 years. Strad's going to give a talk tomorrow about Android. We started working on an Android app. Maybe Android will spread the word enough. Everybody will put this on their phones. It'll be great. We have some other Android apps that use I2P. But one of the most interesting things is when these laws happen in certain countries or things get in the news, and all of a sudden we'll get a Russia users in. And 2010 was France. There was some law in France about privacy or 3 strikes or I don't know. Or there was an article in a newspaper, and poof, all of a sudden we had a zillion French users. In 2011, the same thing happened in Russia. A website came in called RusLeaks, I think kind of like WikiLeaks. And a bunch of new Russian laws, and actually Russia hasn't slowed down on adding new laws. So a lot of the big bumps that we've seen over the last few years have come from Russia. And right now, almost, I think, half our users are from Russia. And which is tough because the Russians, as a community, don't speak a lot of English. They're off in their own IRC channels and doing their own thing, which is fine, but it means the communication paths between us and the Russian users isn't so good. Another thing we tried was plug-in support. Add whatever you want into I2P. We're going to make it easy for people to add features and gadgets to I2P, and that'll make it better. Here's an example of growth gone wrong. Something called congestion collapse. This is a graph of tunnel build success from 5% up to 50% build success, and tunnels is when you're building a pathway through your peers. So you can then send data. So first you get an agreement from all the peers that they're going to let you pass data through them. And if they all agree, then for the next 10 minutes you can pass data through those peers. If somebody says no, well then you have to go try again, ask a different combination of peers. If people keep saying no, well then you keep clogging up the works with more and more build requests. And that causes something like this. And congestion is something that's hard to predict. As you can see, things were doing great until they weren't. And then it's hard to predict exactly what it is that made things better. All we knew is that this is certainly our busy period. This is UTC, so between, as usual in the evening, European time is our busiest time. And we'll talk about that more tomorrow. This is just an example of a growing pain that we had along the way. On the other hand, this is a chart of from early 2011 to early 2012. It's not completely accurate, but according to that chart, you could say we grew by about a factor of 4 or 5 that year. I think this was during the Rus leaks time. That spike there in October may have been the Rus leaks. And so sometimes we see growth, we're not really sure where it comes from. We have to kind of work backwards, do some Google search as well. Was there something in the news? Where did this come from? Was there, then we go back, start looking at Twitter or people tweeting about things. So you never can tell exactly where the growth is coming from. That doesn't come out, but this was not a video, but a picture somebody did, I2P at night. I can see it here, you can't see it too much there, but that's North America, that's Europe. There's a little dot for where all the people are that are running I2P. Sorry, it didn't come out so well, but it's kind of interesting. And I think this might have been before the Russian invasion. But sorry, it didn't turn out so well, but that's okay. Again, these are just examples. Let's talk about the last few years. Again, constantly we're struggling to talk about what will bring new users in, what works, what doesn't. Is it the content? Do we need content on I2P to bring people in? Do we need a better search engine for I2P? Do we need to get DuckDuckGo, for example, a really good privacy-respecting search engine to set up something on I2P? Maybe do we need Facebook on I2P? Facebook's on Tor now. I got Alex Muffet set up Facebook on Tor. Maybe that's what we need. If Facebook was on I2P, would everybody use I2P? Would we get big? I'll show a picture later, I think, but we have a search box on I2P. We added it and then immediately hid it because we couldn't find any search site existing now that could really hide all the worst of the worst. And if you want to give people a good impression of I2P, and it is almost all clean and wonderful, helpful stuff. So we want to put that in front of people. And if we can't find a search engine that can competently filter out the ugly stuff, we're not going to enable that. Some other interesting websites that have shown up, markets, darknet markets, channels, which are always interesting spots for discourse on the internet. We got an award from DuckDuckGo. I2PD is a C++ implementation of I2P. I2P, the main I2P implementation is Java. There's a lot of Java haters out there, even though most of the Java complaints has to do with the Java plugins for browsers and not for software written in Java. So Java, as we use it, is actually very secure and a lot more secure than most programming languages. But Java has a very bad reputation both because of JavaScript, which is nothing like Java, and the Java browser plugins that nobody should be using. We've also had applications bundling I2P. Is that the way to get everybody to use I2P, is hide it inside something else so they don't even know they're using I2P? Views is doing this. Views is a BitTorrent client, a very popular BitTorrent client. And Views has really taken off this year and is now about half of our network, believe it or not, is Views client. So about half of the people, and it's a plugin inside Views, so about half the people running I2P, I don't know if they may not understand much about I2P at all. And then we have I2PCon. Maybe that'll work. Maybe this will be how we grow the network. So that's the last 15 years in 10 minutes or so of how we got here. So let's talk about where we are now. And again, I haven't really explained what I2P is, but that's coming, I promise. As I said, we're not taking a direct path to get there. So hopefully you're not all stressed about it. Anybody stressed? Yeah, well.
Get the bus driver.
Yeah. He's stressed the bus is coming. Yeah. Here's the last year. Estimated total routers. This is probably pretty close. I'd say 25 to 30,000 users of I2P. This is at any time. I think this is unique IPs over the last month. So this is one appearance in 30 days. We will count as a user, at least on this graph. That number is probably right within 50%. I'd say we're probably somewhere between 20,000 and 40,000. The best guess is about 30,000. So not bad, not bad. When JRandom vanished, there was probably about 1,000 users. So we've grown by about a factor of 30 in 10 years. It's not bad. For a lot of years, we're doubling every year. This year is kind of flat, and even with the views people, this bump there is from views, and this graph doesn't show that that's a doubling. We think a lot of the views users, maybe they don't leave it on all the time. Maybe it's more transient. So we're not real sure. One thing is that taking statistics, taking a measure of the network is rather difficult. So the lower graph is new routers. That's in the last day. So you see every day we're getting 500 or 1,000 new users. But maybe we're also losing 500 users every day. So it's a wash. So interesting.
Changing IPs.
Yeah, and I said this was unique IPs, but it might be unique router ID. I'm not sure. Yeah.
Those numbers are always
Yeah.
really
Yeah.
variable.
Yeah. All these numbers are bogus. See this? Just ignore anything on the left. Don't ignore the y-axis because absolute numbers don't count. Like this graph shows that we had a big growth, or at least bigger than the other one. This is router versions, and this shows you that we did about 8 releases in the last 12 months. And this is something I'm extremely proud of, not only that we are doing 7 or 8 releases a year, but we've been doing this for about the last 10 years. And the other thing I'm very proud of is that this is actually the installed base. So our users are upgrading to the latest release because we have automated update. The update's automatically downloaded from those almost centralized servers that we talked about. And they find out about the update through those almost centralized news servers that I talked about. And they download them, and then all we do is ask the user, click to restart. You already got the update. All you got to do is click. And with that mechanism alone, you see that we're up to about 90% of the people are on the latest release within 1 to 2 months after the release. And that helps us tremendously because, as I said, it's so hard to diagnose this network. It's so hard to figure out what's going on. And the best way to figure out what's going on is to wait till almost everybody's on the latest release. Because how can you fix something if only 10% is upgraded to the latest release, right? So very proud of this, and it really helps us. And this also shows you how hard we've been working to make this better. And we have a picture like this for every year going back many, many, many years. Here's another picture. This is all the routers that my website, stats.i2p, knows about. This is if you've made an appearance once in the last month, then it will make a note of it. If doesn't mean my router sees all of your routers. It doesn't, so I don't have a complete view of the network. It's not a special godlike node or anything. But you can see, again, there might have been the views bump there in May and June, and or actually starting in March, and maybe it's tailing off a bit. So how do we get here? Well, I just said that the beginning part of the talk was how we got here. That was on the marketing side. So now I'm going to go back and talk about technically how did we get here? What does I2P do, and how did we get to knowing what it does, or to implementing that? And so you know what I said was going to be in any talk about crypto. Remember? Alice and Bob. So Alice and Bob are back. So Alice wants to talk to Bob, but let's put a couple of constraints on it. We don't want Bob to know Alice's IP. We don't want Alice to know Bob's IP. And we don't want anybody in between to know what they're saying. And we probably don't want anybody in between to even know that they're talking to each other. Okay? So, if we can figure out how to do that, then we will have both anonymity and security. Alice doesn't know Bob, Bob doesn't know Alice, and nobody in between knows anything. And nobody in between means your ISP, means somebody else sitting in this room that's not Alice or Bob. Hopefully it means the government either, but that gets really hard. If you got governments that can build data centers in Utah, it might be impossible to prevent that, but we're going to try as hard as we can. So, that's the problem. What else? What else might Alice want to do besides talk to Bob? Alice might want to talk to Google. Alice might want to go to some website. Say, I don't know Bob. I don't want to talk to Bob. I don't have any way of finding Bob. What I want to do is get to regular websites, but I don't want Google to know my IP. And I don't want anybody in between to, again, know that I'm talking to Google or Yahoo or Facebook. And so those are really two separate problems, right? Does Alice want to talk to Bob? Does Alice want to talk to Google? So how do we do that? How do we implement this system where Alice can talk to Bob or Alice can talk to Google, but yet it's not a direct connection so that there's anonymity? And for that, we need a new crypto person. And after A and then B, well, of course, there's Charlie. So when you get to Charlie in crypto, now you're getting complicated. Okay? So to build an anonymous network, we need a whole bunch of Charlies. That is, people that are going to help route the data from Alice to Bob. But we don't trust the Charlies. We don't want them to spy on us. They can't spy on us, and they can't know that this traffic is going from Alice to Bob. Or from Alice to Google. And for that, and I'm sorry, the words don't come through very well, but what's next after Charlie? Dave. So we got Dave up there, and Dave's going to be the last guy before you go to Google. So this is how we just got anonymity, is we route from Alice through 3 Charlies before we go to Bob, or from Alice through 3 Charlies and then to Dave and then to Google. And if you do that right, and you do the setup right, so that you don't, again, because we talked about having agreements that these Charlies have to agree that they're going to route the data. But they can't know who's asking. So when you ask a Charlie, will you route data for me? He can't know who that's coming from. And he has to send the reply back to Alice, say, yes, it's okay. Well, how do you get that reply back? Again, keeping anonymity. So the other thing we talked about is not just anonymity, but security, and that is encrypting the data that goes between Alice and Bob, or between Alice and Google. But wait, Google's not running this software. Google's not in this cloud. Google's not running our software. That means it can only encrypt from Alice to Dave. And after that, it's not encrypted from Dave to Google, unless, of course, you're running SSL or HTTPS, the secure version of web browsing. And then that's encrypted end to end. But we can't help with that, because Google's not running our software. So I brought back the donkeys or the bunnies because I had to get the graphics from somewhere. So let's call these donkeys attackers. Let's say all the donkeys are evil. So where could an evil donkey be? Well, it could be anywhere. Could be outside our network. Could be inside our network. Could be one of those Charlies. Or maybe he's just watching. Maybe he's just watching the other Charlies. Maybe he's friends with this Charlie. So maybe the Charlie isn't evil, but he's friends with that bunny, donkey. I still can't decide. Maybe there's an evil bunny right there. He's Bob's ISP. Maybe Alice's ISP is evil. And of course, the really tricky one is if Dave is evil. If Dave is evil, you got a problem. And it's very, very hard to protect against Dave being evil. It's hard to protect writing software here. And of course, if Google is evil or there's somebody next to Google that's evil, that's very difficult too. But those are some examples of the scenarios we have to think of along the way. Here's some. Let's put some names on some of these bunnies. The NSA, Verizon, Great Firewall, China, your ISP, your mobile ISP, your Starbucks that you're sitting in. All those, it's not going to be easy. So for the last 13 years, this is what we've been doing. We've been making it go faster. We've been enabling the growth so that we could handle it when new users came in. We've also been reacting to that growth. Sometimes the growth comes in and things go to hell, like that congestion collapse graph that I showed. We make it more reliable. Security, this is a complex set of software, so there's not only just regular bugs, but there's bugs that could... there's bugs that could just make the software crash or not work or be slow. But then we also have to worry about the bugs that could expose your IP or could compromise the security from some attacker. Maybe could reveal your identity to Bob. And as I showed here, we're not in control of everything that Alice is running or Bob is running or Google. All we can control is what's in here. So it's a challenge. But these are some of the things we've been working on the last 13 years, believe it or not, and it still is not perfect. But that's okay, because we started publicizing it. But we really don't push it hard in China, and we have very, very few China users. Because, well, let me back up a minute. Let's talk about the misery of exit nodes. And Dave is an exit node, in case you hadn't guessed. Exit node is Tor terminology. We call them out proxies. I think you'd be crazy to run an exit node. I don't know if I know anybody that does. I think even if you're legally on firm ground, that doesn't prevent you from getting a subpoena. And subpoenas are a hassle at best. Subpoena means you got to go find a lawyer. And there's so many bunnies out there. There are so many bunnies out there, right there, sitting outside the exit node. Even if you trust Dave, but Dave, you don't know who Dave is, or Dave doesn't know who you are. So how can you trust Dave? It's a very, very tough problem. And in many countries, this is all that the users are looking for. In many countries, Alice doesn't want to talk to Bob. Alice only wants to talk to Facebook or Google. Alice doesn't care about Bob. They're in a country where their government is blocking them from getting to Google, and they're looking for a solution to that. So let's talk about, with that background that, as I said, was not an explanation of what I2P is, but maybe you're starting to absorb a little bit. So let's talk about the difference between Tor and I2P, because most of you, I'm sure, have heard of Tor. And so here's an architecture of Tor and some numbers. Tor has about 2 million users. They are all out here. They are not inside, they are not Charlies. They are not routing data for you. These are people that just go in, they route the data through the Charlies, and then they go to Bob or they go to Dave. But these 2 million people are not routing data for you. They're just leeching capacity from the network. There are also 9 directory authorities. These are run by trusted members of Tor. And these directories run software that votes on who are the good Charlies and who are the bad Charlies, and who are the good Daves and who are the bad Daves. So Alice checks with the authorities and finds out, do we trust Dave or not? And if somebody reports that Dave is evil and is messing with their traffic, well, then at some point later, the directory authorities all type in, okay, don't use that guy. And there's also about what they call hidden services, 3,000 hidden services or websites inside the network, or Bobs. And inside here, the number of routing Charlies that are routing data for you is about 6,000 relays and 3,000 bridges. So, you all want to know what the difference is between Tor and I2P. Notice there's no mountain of directory authorities voting. We only have one exit node. What did I say? How many? There are 1,000 exit nodes for Tor. We have one. We trust him, sort of. Also notice, this is a key, that Alice and Bob are not out here. Alice and Bob are inside. So Alice and Bob are Charlies too. Everybody's routing data for everybody else. So all of our 30,000 users are relays, more or less, with the exceptions that I noted back in the slide, about slide number 3. As far as how many hidden services we have, if you count a hidden service as something that's only accessible inside the network, well, we have about 300 of them if you just count websites and IRC servers and so on. But if you count all those 15,000 views clients, which again are servers because I can connect to this BitTorrent client to receive data from him. So if you look at it that way, we have about 15,000 hidden services running in the network. Let's talk about some things that maybe haven't worked so well as far as spreading the word, growing the network. Not sure if Conferences has done it. Don't think so. We've never given a talk at DEF CON. Not sure if that's because we aren't well organized enough. Not sure if we gave a talk like this, if we'd get 1,000 new users or 5,000 new users. I don't know. We've never. We tried to get grants. We thought, oh, if somebody gave us money, well, then everybody would see the news that somebody gave us money, and they would all go install I2P. I don't think that worked. DuckDuckGo did give us $5,000. Probably nobody saw the news. Don't know. We need content. Does content bring people to I2P? If we had Facebook as a hidden service, if all your favorite websites were hidden services, would then you all use I2P so you could connect to them anonymously? Or would you still just be logging in with your username so they know who you are anyway? And it's pointless to hide your IP from Facebook because Facebook knows everything about you. So is Facebook, if you're not in China, does it make sense to use Facebook over an anonymous network? Probably not. If you're in China, maybe and it's blocked, then that makes sense. But as you saw from the previous graphs, it's always been a little bursty and random when we get new users. And that's true for Tor as well. Things in the news like Snowden, WikiLeaks. At one point, the U.S. government was pushing for people to use it to talk to people in Iran or for people in Iran to use it. Maybe everything pays off eventually. Maybe it's all just one big marketing campaign, and 3 years later, somebody says, oh, I remember about that I2P, but now I really need it. And they're going to install it. So it's a little bit of a mystery. As you can see from me standing up here awkwardly trying to explain it to you, I2P is still a hard sell. We don't have prepackaged presentations. Every time we go to CCC and sit down around a table, we all laugh at each other trying to explain it to other people, whether they speak our language or not. It's always a little comical, always a little humorous. See Echelon back there laughing. He's one of the best at sort of explaining it. As I said, many countries, many users in a few countries, they just want to get to the internet. They just want Tor. They just want to talk to Google. We think that's true for the billion people in China. In a lot of these countries, there aren't strong copyright or privacy. There aren't strong copyright problems, and a lot of people are using I2P for perceived benefits of avoiding somebody coming after them for sharing a file. And in a lot of countries, nobody cares about that. Nobody's coming after them for that. So, if so, then maybe they don't need us. It's more of a platform than an application, I2P is. By itself, we just told you this is how Alice can talk to Bob. Well, but what data does Alice want to send to Bob? Well, that's an application. Is it an IRC chat? Is it an email? Is it some file you want to send? Do you want to share a file where I send a file to Bob and he keeps it for me? So that's the application layer. But we don't ship a lot of applications, and so by itself you could say I2P is just a pipe, it's just a tube, and you do with it what you want. But that again makes it a challenge to sell it to people. They say, well, what can I do with it? And we say, well, whatever you want. Earlier this year, we started moving to the Tor terminology, such as hidden services. We've called them EAP sites before, which EAP site is kind of a bad joke. Nobody understands. You can't pronounce it, can't spell it. So we thought, well, Tor has become huge in the last 10 to 15 years while we've become a little bigger. So maybe it would help if we use the same language that they do, the same terminology. Although they now decided that hidden services has a bad connotation. And it makes them sound evil. Don't want to be hidden. So maybe they're talking about moving away from hidden services. So I guess we need to talk about keeping it or moving along with them. I don't know. Oh, here's the picture I said I was going to do. This is our router console. When you first start I2P, this is what comes up. And wow, it's... We'll talk about the one thing that I mentioned before. Nobody sees this part because I hid it. Because eapsites.i2p, which is one of the search engines, and everybody else we've been able to found really can't filter anything to our expectations. So we hide that so that users don't type in the wrong thing. But I don't know, maybe we should expect more of our users. Maybe not. Sometimes we talk about, well, tomorrow we're going to talk about existential threats. What are some of the threats to this network? How could the whole thing get shut down? How could it all go down the tubes? And maybe getting a bad reputation might actually be one of the worst threats. So maybe that is very important to not enable that for people. Here we have a list of development sites. It's not really of general interest. If Facebook showed up on I2P, we'd put them up there. So our recommended, they're kind of recommended sites. We don't say recommended. But we tried to make this look a little bit like a cell phone app, like a cell phone home screen. So again, this is just, here's the little news. Remember, this is what comes from Echelon and Jeff. That's the little news part I was talking about. So again, what does it do? Is this the best we can do? Definitely not. Is this how do we explain it better? How do we pop it up in front of people where when they install it, it does something or it leads them somewhere? But yet, if we're only a pipe, then we say, here's your pipe. So we're kind of saying, here's our pipe, and here's a few things you can on the other end of the pipe. We don't think that's sufficient, and we got to do better. We might even need a better background. Maybe we can set the peanut gallery on that. Have them look for a better background. So again, not perfect, not even close to perfect. So here's the coming challenges. Complete with a typo. Keep doing what we do best. Even while Tor has, I think, 30 paid employees, a budget of millions of dollars, they are finally turning their attention to hidden services, which they haven't done for many, many years. We think we do hidden services much better than Tor because it's all we do. If Tor starts doing better than we do at hidden services, we might be in trouble. So we have to keep up. We have to stay ahead. One thing that's very lucky, or thank JRandom, is that a lot of the cryptographic primitives that were selected back in 2003, which is the basic algorithms and mechanisms that we use for the cryptography, for the encryption, I think JRandom made a lot of better choices than Tor did, and they picked at the same time. JRandom made stronger choices that have lived longer. Some of Tor's things, they're really, it's starting to be on the verge of not so great, kind of weak, and ours have a little bit more of a lifetime, but we are also migrating. Not all of our cryptographic choices are great in 2015, and we are also migrating, and we have to keep that going. Again, it's another challenge that technology keeps catching up to us. We can't stand still, or every day the primitives that we use are weaker because there's more CPU power available to people than there was before. We need to restart growth. We need more of everything. It includes more users, more devs, more testers. Most of the people in the yellow shirts in this room are not coders, but yet they are all contributing to I2P, every single one of them. You don't need to be a coder. We need lots of things. And as you see from this talk, it's a community. It's not a bag of software. It's a community of people. And hopefully you can talk to us again in the next break. We do need more of everything, and we're going to talk about that again tomorrow. So join us. We need you, and if you want to secure your privacy, you need us. Any questions? Yes, sir.
Okay. Actually, I have two questions.
Okay.
The first one is, we have a exit node, right? Which I think is situated in hardware, right?
Mm-hmm.
Is there another one? I can set it up? Can I set it up? Is there another one?
Yes, you can set one up. And one problem is our software doesn't handle more than one very well. So if somebody really volunteers and is serious about it, then we need to get better on our side to make it detect which one's working and which one to use, switch back and forth. Also with exit nodes, because they are in a position where you kind of want to trust them at least a little bit, we really want to get to know you before we say, yes, we're using you as an exit node.
Yes, the other question is, are the deep sites centralized or not?
Hardly. You can run more than one server as the same deep site. You just need to copy over the the content and the key file for the hidden service you run. If you copy it to 20 servers in I2P, you run the same content and copy the content. You run the same service on 20 different servers.
So it is kind of, it is in between core and FreeNet, because in FreeNet you can...
Yeah.
I2P doesn't do it on its own. You need to do it on your own.
Yeah.
If you just click in the router console, there's a server inbound, server included. It's Jetty currently. If you just started and copy content in it, it's just one centralized server. But if you copy the key file and the server, the content to another one, and start it, it's automatically on two.
Yeah. I think the answer is that if for redundancy, we do good if you want to just add a second one, just 1 plus 1. If you were Facebook and you wanted to run 50 mirrors, it would break.
How many exit nodes do we have in the exit node? Just one?
One, right?
One official.
Yeah, one official.
More or less official.
Yeah.
They
Okay.
in Norway.
It's the
More
same.
do exist, but they are not public known.
We-
Some I do know over some people I know, but they are not official into the distribution being run because we don't know them, or we don't trust the user, or we say it's such a small test setup, we don't want to include it now. We don't know.
Okay. We're running out of time. We can talk about it more later. I want to get to some other questions. Yes, sir.
I'll ask a different question. You had, I saw a .I2P looking like a top-level domain name.
Uh-huh.
Can you explain, is that like a properly registered domain name, or is it only working inside the I2P network?
I will give you the short answer, and we can talk about it more later. That's what's used internally to recognize that it's an internal name and that it doesn't go out to the network.
Conflicts?
It does not conflict with anybody now. There is a mechanism to register a name as reserved, that it will never be used ever. That mechanism is under dispute and discussion and a meta discussion all of its own as to how to accomplish that. There are people working toward that. Looks like Tor is going to get through that process with Onion very soon. The rest of us may have more of a challenge to get through that. The one good news is the official rules are that you can't have a number in a TLD. So we don't think that anybody would ever really register I2P, at least for today's rules. Any other questions? Yes, sir.
So what is your project's opinion of malicious software implementing I2P? For example, CryptoWall recently had a big, in the recent version, it was reported that it was using I2P as a dial-out mechanism to try and not be seen inside a network, for example, as well as other botnets that may have shown up.
We're not a fan because, as we said, our reputation or losing our reputation may be one of the biggest existential risks to the project. Also, they're not running the latest versions of things. I'd almost like a botnet better if it stayed updated. But as you saw those charts of updates, if we get some big botnet and they stop updating, that could be a disaster as well. And of course, we don't have contact with the people running these things. This will be a big topic of discussion tomorrow. And so save your follow-ups on that, and we're going to be talking about the botnet and stuff a lot tomorrow. Yeah, Jay?
I got one question I think everyone's asking. What is that yellow guy? Is he holding a bomb? Is he a mosquito? What is he?
We covered that. Where were you?
I was outside doing the door thing.
Well, so ask somebody to fill you in during the break.
It's a bomb, right?
Yeah.
What am I doing here?
Okay, we're going to take a very short break, not a 25-minute one, but more like a 10-minute one to set up a table, and then we're going to have a round table. So take a short break. Don't go far. Thank you.